So welcome everybody to this latest video on scatter diagrams, in which in this video we'll be discussing correlation and relationships. So as mentioned in the previous video, one of the main purposes of drawing a scatter diagram is to see if a relationship exists between two variables when compared. Now, a relationship exists if the points show what we call correlation, and the stronger the correlation, the stronger the relationship. So let's go into detail about what correlation actually is. Now, when looking at a scatter diagram, to a non-mathematician it may just look like a load of random points scattered amongst a set of axes. However, what you're trying to look for when looking for correlation is seeing if the points form to make a straight line. Now, that straight line could either be heading upwards, it could be flat, or it could be going downwards. Now, if you have your set of points that join together, and if I just draw it on this set of axes, and you can see here that these points make almost a perfect diagonal line that's starting high, ending low. Now, if your graph looks like this, then you could say that it's got strong negative correlation. If you've got points that are all over the place, but in its entirety look as if they're going down, then we can say that it's got weak negative correlation. And again, one way to look at it is if you kind of just try and draw two lines, and let's pick a different colour to yellow because I don't really see that. So for example, if I just draw a line where those lines are, and above and below, you can see that that tube is going downwards. And likewise, it's a bit sort of chunkier on a weak negative, but again, those points look to be going in a downward direction. Now, if we're looking at the opposite direction, so for example, if your points look as if they're starting low and heading high, but don't quite make a perfect line, then you could say that it's got weak positive correlation. And a strong positive correlation would be where the points make almost a perfect line. Now, in terms of the gradient of that line, it doesn't really matter as to more the direction. So if it starts low, ends high, it's got positive correlation. If it starts high and ends low, then it's got negative correlation. And again, if I kind of do my dashed lines, you can see that grouping all of those points, the smaller the tube, the stronger the relationship. Now, if I had points that were, let's say, where the gradient was a little bit stronger, so for example, if it looked like this, then that still would show strong positive correlation, because if I join those green dots together, it would make almost a perfect line. Now, if, and this again, this is entirely possible, if your points are all over the shop, so all over the place, and doesn't quite make a formation of a line, then what you can say is that it's got no correlation. Now, when an exam question or a class question or a homework question asks you what type of correlation, it's always important to not only state what type of correlation, but also the strength of the correlation as well. And that's usually going to be worth an extra mark. So when in an exam, if you see a question asking you what type of correlation does this scatter diagram show, and it's worth 2 marks, you get 1 mark for saying positive or negative, and another mark for describing the strength. Now, again, the kind of keywords you want to be looking for are strong and weak, positive and negative. I wouldn't go for kinda or a little bit positive, a little bit negative, or a little bit positive. You want to use those keywords of strong, weak, positive or negative. Now, at a higher level of statistics or mathematics, correlation can also be represented by a number as what we call the correlation value, and it's usually symbolized as the value of R. Now, here your R value that represents correlation is a number that's between -1 and +1. -1 means that it's got strong negative correlation, 1 means it's got strong positive correlation, and a value that's close to 0 would mean that it's got no correlation. So if you were looking at a scatter diagram, so let's say we've got these points here, and here you can see that those markings make almost a perfect line. So that would be R equals -1. Why? Because it's got a strong negative correlation. Now, if I, let's say, just altered some of those points and just had it slightly out, so let's say I had a point that was here and this point was there, then that would affect the correlation value, and it will now have maybe a value of minus, let's say, 0.92. So something along those lines. So again, if I'd, let's say, points that looked, let's say, like this, though this shows weak negative correlation, so I would say that that's got a value of minus, let's say, 0.6. If I had a graph that had points all over the place and I couldn't see a visible diagonal line anywhere, then I would say that that's got R value of a number that's close to 0. And again, even if you had a value of, let's say, minus 0. Let's say 1 or positive 0.15, then I would still say that that is closer to 0, so therefore represents no correlation. If I had weak positive correlation, so again had points that looked, let's say, like this, then I would say that's got an R value of positive, and I would say probably about 0.6. And again, if I had perfect correlation that looked like this, then that would be an R value of positive 1. So sometimes you might have to have like a mix and match question where you might have to match the R value with the graph, but again, it's always important that you establish which it is. And if you're ever asked to estimate what an R value would be, well, there you go. You can just kind of use this scale and go from there. And in terms of scales, I would say, again, it's up to a decision on this one, but I would say anything up to 0.75, this would represent strong negative. Anything beyond between minus 0.75 and maybe 0.35 would represent weak. And then likewise, anything between 0 and 0.35 I would say would be no correlation. And up to 7.5, so this would represent weak positive, and this would all represent strong positive. But again, that's open to discussion. Don't quote me on those numbers, but I would say that's a rough estimate to go for. So the next thing we move on to is looking at relationships. Now the main thing that you are looking at is when you are asked, let's say, a more conclusion part of the scatter diagram question, which again will add more of a higher level or more marks to it. It's important you know the difference between, and read the question carefully, because there is a strict difference between a correlation and the relationship. Now, if a scatter diagram shows correlation, whether it's positive or negative, doesn't really matter, then you can assume that a relationship exists between the two variables. Now, if your diagram shows what you class as being positive correlation, then basically what the relationship is going to be is as one variable increases, the other variable will also increase. Now, the word variable will depend on what's on your x-axis, so this would be what's on your x-axis, and this would be what's on your y-axis. So when you're talking about descriptions in exams, I certainly wouldn't use the word variable. I would replace the word variable with whatever is sort of the scale is used on the x and y axis respectively. Now, if you've got negative correlation, then basically what this means is as one variable increases, the other variable will decrease. So if you've got, let's say, x and y data and it shows negative correlation, you would say as x increases, y decreases, and that'll be absolutely fine. Now, if you find that your scatter diagram has got no correlation, so the points are all over the place, then no relationship exists between the two variables. So even if there is no correlation, a relationship does exist. It's just that there isn't one. Now again, the stronger the correlation, the stronger the relationship. So although a graph may show positive correlation, if it's weak positive correlation, then there is kind of relationship, but again, it's not something that you would bet your money on or bet your mortgage on. Although you may be too young if you're watching this video with having a mortgage, but you never know. So let's have a look at some example questions where we are asked to talk about the correlation and the relationship. So in this first example, you can see on the scale, it's basically comparing age to salary. So we're basically seeing if a relationship exists between how old someone is and how much they earn. Now, looking at this scatter diagram, I would say that it's got weak positive correlation, because you can see that if I kind of do like a boundary of where those points are, they are going in a upwards direction. So in terms of commenting on the correlation, I would say it's got weak positive correlation. And for 2 marks, I would get 1 mark for stating weak and 1 mark for saying positive. Now, the positive is probably the most important one. The weak would be a bonus mark. Now, when describing the relationship, this is where you kind of need to make sure you're reading the question carefully, because if you give a relationship description on a correlation question, you're not going to get any marks. If you then state, if a question asks you what's a relationship and you say, oh, it's got weak positive correlation, you're not going to get any marks, because it's not asking you what the correlation is, it's asking for what the relationship is. Now here, because we've got weak positive correlation, we can say that now what's on our x-axis is age, so as age increases, and then what's on our y-axis, salary increases. And that would be a perfect description of the relationship because it shows weak positive correlation. So let's have a look at another question. So here we're comparing the age of a car and its value. So here you can see that if I kind of do like a rough estimate to what those lines show, we can see that because there is quite a big gap between those two boundary lines, that we could say here we've got a weak negative correlation. And what does that mean? Well, it means that as a car, or say, yeah, it is a car, gets older. So in other words, as age increases, the value, which is our Y sort of scale, decreases. So as one gets with negative correlation, as one gets bigger, the other gets smaller. And let's have a look at our final example. So here we're looking at test scores and the hours spent revising. So again, might be something a little bit closer to home. So again, looking at this particular diagram, now you can see here that looking at it, the points, we've only got 7 points. Again, it's a decision, would you class that as being strong positive correlation, or would you see it as weak positive correlation? Again, it's open to interpretation. Now, I personally would say that because there's a gap here, and again, one way of looking at this, which will be our next video, where if we draw a line of best fit. So if I draw an actual line and try and match it up to each of those points, now you can see here that with my line of best fit, majority of the points are relatively quite close to that line. So I would say that it's got, and again, it's really open to sort of interpretation, but I would say, do I go for weak or do I go for strong? I would say let's go for strong. So we say it's got strong positive correlation. Now, if you have got a question where it's a little bit dubious and you don't really know whether it's weak or strong, that question will usually be worth 1 mark. Now, if you've got a question that's only worth 1 mark, then I would usually just opt for whether it's saying it's positive or negative and correlation, and that's it. If it's only worth 1 mark, no point sort of putting yourself on the line by stating the strength. But if it is worth 2 marks, then obviously you're going to need to add that strength on there. Now, in terms of describing the relationship, well, as it's got positive, so in other words, what does this mean? So as the hours revising increases, the test score percentage also increases. Now you could rewrite that sentence to make it more sense. So you could say, well, basically what this scatter diagram shows is the longer you spend revising, the better your test score will be. And that is going to be absolutely fine in terms of wording for a relationship question. So again, just make sure that when you're given this test, you could get asked both of these 2 types of questions on exams, but more often than not, you may only get asked one. And it's always important that you recognize the difference between describing the correlation and describing the relationship. Now, we'll put some practice questions in the description below for you to practice everything that's covered in this video.